Bismillahirrahmanirrahim. In this session, we will discuss multiple images in a mirror from O-level physics, written by Tom Duncan and Heather Kennett, published by Hodder's Education. An ordinary mirror silvered at the back, at this side. This is an ordinary mirror. Several images of one object. So this is one of the object is placed here, and we see the reflection and images at this point, this point, this point, because of the error. So this makes this object a blurred. So because of multiple reflection inside the glass, figure this shown, these blurs the main image. So this main image is this one, but this is I1 and I2 is basically blurring this image because of multiple reflection. So which is formed by one reflection of the silvering, especially if the glass is thick. If this glass is thick, if the thickness of this glass is more, then this blur phenomena will be more frequent. If the thickness of this glass is small, or thin glass is used, then this blurring phenomena will die out or will be removed. So these blur the main image I, which is formed by one reflection at the silvering. So this is blurred by these two, especially if the glass is thick. For this thick glass, especially this phenomena occurs in thick glass. But in case of front polishing mirror image, this can be also be tackled, but in that case the problem is absent in front silvered mirror, but such mirrors are easily damaged. So if you polish at the front side, then this phenomena can be replaced, this blurring phenomena of multiple images, but this can easily be damaged. So totally reflecting prism, the defect of mirrors are overcome if 45-degree right angle glass prisms are used. If we use this 45-degree glass prisms, this is 45 degree, this is 45 degree, 90 degree. If we use this kind of glass prism, the critical angle of ordinary glass is about 42 degree, and a ray falls normally on a face PQ. This PQ of such a prism hit surface PR at 45 degree at this angle. This is normal, so this is 45 degree, so it will be totally internally reflected because the angle of reflection is more than 45 degree, 42 degree. So this is 45 degree, which is more than 42 degree, so no refraction will occur, but reflection, total internal reflection, the total internal reflection occurs, and the ray is turned through 90 degrees. So this 45 degree is this incident angle, and the reflection will be 45 degree, like this. So this way this problem can be overcome. So the total reflecting prism replaces mirrors in good periscopes. So in periscopes we replace the mirrors which creates multiple images, as we discussed earlier. So this in a periscope we use this kind of prisms which remove this multiple blurred image formation. So total reflecting prism replaces mirrors in a good periscope. Light can be reflected from 180 degree by a prism like this. So this is not 45 degree, and then 45 degree, and this is 45 degree, and this is 45 degree. So it will reflect like this. So we can understand the phenomena by just placing perpendicular on it. Light can be reflected from 180 degree by prism. So light here, and finally we'll get this. So this is 180 degree change. This happens in binoculars. This kind of phenomena happen in binoculars, so which is very, very important. And light pipes and optical fibers, lights can be trapped by total internal reflection. This is the way the total internal reflection occurs, and pipe along a curved path. A single very thin glass fiber, an optical fiber, behaves in the same way. If several thousand such fibers are taped together, a flexible light pipe is obtained that can be used, for example, by doctors as an endoscope to obtain an image from inside the body, or by an engineer to build up some awkward spot for inspection. So this is endoscopy, and for this endoscopy we can see the internal organs of the body. So this is endoscopy in use, and here the trachea, the windpipe viewed by an endoscopy. Endoscopy is used to trachea can be observed, and this is all because of the total internal reflection. Increasing optical fibers are being used to carry telephone, high-speed broadband internet, and cable TV signals as pulses of visible or infrared lights. The advantage over copper cables for telecommunication purposes are that the use of light allows information to be transmitted at a higher rate. So the data transfer rate will be much higher if we use optical fibers instead of using copper cables. So, and the data is more secure because the cables are unaffected by the electronic interference. So in case of light, it will be unaffected by the electronic interference. This can be used over long distance since they have lower power losses and made up of cheaper material, and they are lighter and thinner and are easier to handle and install. However, they are not as strong as a copper cable and can break if bent too much. So this is fragile, but this is highly economical, and it data transmission rate is very high. So high speed broadband connections or use this optical fibers, and which works on total internal reflection phenomena. In the next topic we will discuss some